So this is Unit 5A, Triangle Similarity. It's our new videos of the new year. Yesterday, or whenever you guys came back from the holidays, you guys learned about the difference between congruent and similar triangles. So today, we're going to look at the specific similar triangle properties. This is the second flap of your foldable. What it's supposed to say is that similar triangles are not congruent. So you cannot say that two similar triangles are the exact same, because that's not necessarily true. But congruent triangles, like we learned before break, congruent triangles are similar. And the reason is, it's the definition of similar. Similar triangles are just dilated triangles. So if you take a triangle and you dilate it by half, and you split all the sides of that triangle into a half, you will have a triangle that's half the size of the original. If you multiply all the sides of a triangle times 2, then you will have a triangle that is double the size of the original. That's how we get similar triangles. Congruent triangles is it's a triangle where you multiply all the sides by 1. So it's still similar by the similar definition, because it does have a dilation. It's just 1, and to give you back the exact same triangle. But similar triangles are not congruent. That does not mean that they are the same. So a lot of these properties will look the same as congruent triangles, but these are specifically for similar triangles. So there's angle-angle similarity. And remember, for congruent triangles, we told you there could not be angle-angle-angle similarity. But for similar, all angles are congruent. And if you only know 2, then you can add those 2 together and subtract from 180 to get the third. So if 2 sets of angles are the same in one triangle as they are in the other triangle, then they will be similar. It does not mean that they're congruent, because the sides could be bigger or smaller because they're dilated, but the angles would be congruent. So angle-angle similarity. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So if this angle is congruent to this one, and this angle is congruent to that one, then those would be similar by angle-angle. Then we have side-angle-side similarity. These two you both saw in congruence. But remember, congruent triangles are also similar, so they can have the same properties. So side-angle-side similarity of two triangles, in two triangles, if a pair of corresponding angles is congruent, and the side including the angles, this should be sides, well, there's 2. Sides including the angles are proportional. Remember, similar triangles are not congruent, they are proportional of the sides. Then the triangles are similar. So if we know that this side is proportional to this side, that this side is proportional to this side, and that this angle is congruent to that one, then you know they are similar. So this is one way that you can denote proportional sides if you do not know them. Another way that you can see it, because remember, they're proportional. So let's say our original triangle was 3 and 6, and let's just say that we doubled it. So this side would be 6, this side would be 12. So you see that to get from 6 to 12, it's times 2. To get from 3 to 6, it's times 2. So as long as both of these are the same number, then they are proportional. They both have to be the same number, though. And then my angles also have to be congruent in between those two sides. Then we have side, side, side similarity. If all 3 pairs of corresponding sides of 2 triangles are proportional, then the 2 triangles are similar. So again, if this is 3, this is 6, and since we're doing 3s, let's just do this one 9. You could take this one and we could multiply it times, let's do 3. 3 times 3 is 9. You would also have to multiply all the other 3 times 3. And 9 times 3 is 27. And 6 times 3 is 18. So look, all of these have to be multiplied by the exact same thing to get the corresponding side. And if they are, they're proportional, and then they are similar. And I think that's all you have to do today.